a very warm and special welcome to all of you joining us today from across the world. I'm Zainab Ayajiwala and I'm the conference producer at Media Fusion, and it's my pleasure to open this webinar and set the stage for what promises to be an engaging and insightful discussion. Today's webinar is a special pre-event session ahead of two flagship industry gatherings, the UTECH Middle East Foam and Polyurethane and Adhesive Sealants and Bonding Expo, taking place from 15 to 17 September 2025 at the Dubai World Trade Center, and UTECH India Sustainable Polyurethane and Foam Expo 2025, scheduled from 13th to 15th November 2025 at the NESCO Bombay Exhibition Center, Mumbai. These events are organized by Crane Communications and Media Fusion, and they bring together the top innovations and strongest voices in the global PU and foam community. Whether you're a manufacturer, researcher, policymaker, or end user, there's something for everyone. A quick word on the UTECH brand. It is a truly global platform with editions across Europe, Dubai, India, and Southeast Asia. Over the decades, become a trusted hub for knowledge sharing and business growth. This year marks the fourth edition of UTECH Middle East and Africa and the second edition of UTECH India. If you'd like to participate in either of the events, please reach out to our team. A downloadable brochure is also available in the handout section of your screen. And for any conference opportunities, feel free to contact my colleague Sheetal directly, whose details are mentioned in the brochure shared with you in the material section. Now, we're excited to share some important updates from our upcoming events. For UTECH Middle East Adhesive Sealants and Bonding Expo 2025, visitor registrations are now officially open. So don't miss the chance to be a part of the region's event for polyurethanes, foams, and advanced materials. Secure your free visitor pass today and be at Dubai World Trade Center from 15 to 17 September. For UTECH ISPUF 2025 happening in India, if you're looking to tap into the rapidly growing Indian PU and foam market, stand live. Reserve your space now and showcase your solutions to decision makers across India this 13 to 15 November 2025 in Mumbai. Links are shared in the chat. Register today and book your spot early. Moving on. So, as for what we've gathered today, our focus is next generation sandwich panels, trends, technologies, and applications. With rising demand for energy efficient, lightweight, and fire safe construction, PUF and PIR-based sandwich panels are at the forefront of innovation. The real breakthroughs come from the chemistry behind them, driving advances in fire resistance, thermal performance, blister control, production efficiency, and sustainability. We'll hear from some of the leading voices in the industry, followed by a Q&A session. Please use the Q&A box at the top right of your screen at any time and do mention the speaker's name so we can direct your questions to them accordingly. Moving on to the main crux of our event now, we are honored to be joined today by an excellent lineup of speakers. Let me introduce you. Mr. Ali Ihsan Cetiner, CEO Alexandria Steel Forming, AlexForm, and the advisory board member for UTECH MEA 2025. He will be presenting on the topic Fire Safety in Focus, PIR Sandwich Panels, and Global Testing Standards. We then have Mr. Shrini Menon, Commercial and Specifications Manager at Kingspan Insulated Panels Middle East. He will be presenting on the topic Next Generation Sandwich Panels, Smart Solutions for Modern Construction. We then have Mr. Satish Kumar, the Deputy General Manager at Metalscope India Private Limited. He will be presenting on the topic Sandwich Panels in Pre-Engineered Buildings, a game changer for industrial and commercial infrastructure. And we have Mr. Ilhan Kurt, Head of Research and Development at Pearl Polyurethane Systems, who will be sharing his expertise as a panelist. Now we'll begin with Mr. Cetiner's context setting remarks, followed by Mr. Menon's presentation. After that, Mr. Cetiner will return with his technical talk, and then we'll move to Mr. Kumar's presentation. We'll conclude with insights from Mr. Ilhan Kurt, who will be sharing his expertise as a panelist. Please note that this session will be moderated by Mr. Cetiner. Just quickly again, before we move ahead, the visitor registration check in Middle East ASB 2025 are open now, and it is going to happen at Dubai World Trade Center from 15th to 17th of September. And for UTECH ISPUF happening in India, stand bookings are open, so please get in touch with the respective team for which the brochures are shared in the materials section. Handing over to you, Mr. Cetiner.
Thank you very much. Thank you very much. Welcome, esteemed attendees. We have a very special lineup of guests here today, and I am proud to be here today in front of you as my colleagues. Between the four of us, there's about a century of experience on sandwich panels. So this platform, I would like to thank the organizers for this platform that they made available to us. And once again, apologies for the technical glitch that I cannot show my face, but hopefully the presentation will be good enough. Today, Mr. Shrini, Mr. Satish, and Mr. Ilhan are joining us, and with Mr. Shrini's first presentation, we'll be touching base on sandwich panels in general, or insulated metal panels, or PUF panels, as you will be hearing these terms throughout the presentations. And he will set the ground, the starting point for us to dig deeper into the topic, and then I will come and talk about the fire safety testing standards, what it means, because this is quite a hot topic, especially in our region here, led by the civil defenses of the countries, and I think it's safe to say UAE is leading the leading country in setting these standards, because it's the first country that came up with strict requirements for products to be civil defense approved to be able to be marketable in the country. So we'll take that as a starting point, and then we'll talk about this. And then Mr. Satish will be telling us about the benefits of using sandwich panels, how easy it is, how fast it is, and how compatible it is with the modern construction techniques. And Mr. Ilhan will be available to answer any questions. We brought him as a backup because he's the most technical person in the production of these forms. So we will rely on him if there is too much technical questions that comes our way. In the end, we are professionals that we produce, we market, we sell, and then we support the use of these products. But he is directly in the kitchen of the form that is being used in these sandwich panels.
Thank you, Mr. Ali. It's my pleasure.
Thank you very much. So without further ado, I would like to leave the stage to Mr. Shrini, if he is ready to start his presentation. While he's getting prepared, actually, maybe I can also talk about a little bit about our industry, because all these years, I'm sure you all experience, panel industry, sandwich panel industry has been a bit of a niche. It has been left a bit in the shadow whenever there is such construction events, insulation or refrigeration events. Although we are always there, there hasn't been a platform for us to come together and discuss where the industry is going, where the novelties, where the innovations are going. So this, I think, is a good start, because the professionals of this industry should really be talking to each other to bring up the level of, let's say, product quality, service quality that the customers really need. So I think Mr. Shrini is ready now.
Good afternoon, good evening, attendees, and thank you, Ali, for the introduction. I do appreciate and thank you for that. Am I audible now? I had some issues logging in. I had to log in again.
I can hear you.
Thank you, and again, a warm welcome to all the attendees, and generally appreciate you taking time off your busy schedules to attend this webinar, and our sincere thanks to the organizers. They've done a stellar work bringing us up so far to this presentation stage. As you can see, I hope you can see my screen.
Yes, sir, we can see.
Okay, right. So let's dive into the first subject heading, which is basically the next generation sandwich panels. Now, most of the attendees, I would think, would be having an inkling of what sandwich panels is all about. It's being used a lot. Sorry, why is this happening? Look, like I said, IMPs or insulated metal panels, as they are widely known in the Western world, panels are known quizzically under various names. I put a note on the right there in red. So it is also in multiple countries and regions, depending on where you're from. You might call a panel a sandwich panel, a puff panel, as the Indian subcontinent more likely calls it. People call it composite panels, foam core panels, thermal panels. I've even heard about structural panels. So whatever you call, let's, for the sake of this seminar, call it insulated metal panels. And as you would see in the points jotted down below, what does an IMP do? Basically, it provides weatherproofing, waterproofing, and that's one of the external functions of the panel, to provide weather tightness to the building. Very importantly, it provides thermal insulation depending on the region or the country you are in, keeping the heat in or keeping the heat out. As Zainab has alluded in the beginning, and probably as Ali will elaborate a lot in detail, there's a lot to do with fire safety in using metal panels. You have to be very careful, and very careful choices are being made and specified across the board. These days, fire safety has become a norm in most countries, and I hope it becomes a norm across the world, because the last thing you want in a building, in the case of an unfortunate incident of a fire, is to lose lives. As well, one of the important aspects of an IMP that it does is it provides acoustic insulation. We have a lot of data centers, which I'll touch upon later, being built, and typically what used to be solid 200, 300 mm block work is now being replaced by panels, because these panels, if it has a stone wool core, it provides excellent acoustic insulation. So in short, what an insulated metal panel or IMP provides is cost-effective, quick construction. It requires minimal post-construction maintenance, and because it's a unitized system that comes off a factory, it goes straight onto the building. It reduces the typical construction time, anything between 30 to 50%, and this has been well documented in various studies. Also, it can be easily integrated with other trades on a building, be it daylight, access equipment or ventilation. It's all easily integrable, so it becomes very desired material or choice of material on buildings. Now, like I said, Ali will obviously dwell a lot on the fire performance, but there are also other testing and performance characteristics that go into a panel selection. And there are multiple characteristics that can be tested of a panel, including its resistance or reaction to fire, air infiltration characteristics. It is the static and even the dynamic water testing characteristics, and the structural performance of a panel, because essentially it basically envelopes the entire building interior space. So it has to have a very good structural performance. We will then touch upon the various cores that are in this part of the world mainly used for the construction of panels, which is PUR core, PIR core and a stone wool core. You will also see a note elsewhere that there is also available other cores like glass wool, or these days I see a lot of uh, natural material like Kingspan, for example, has come up with hemp and jute fabric mixture to make a board. Very soon it might become a panel. So we'll talk about it later. So as we see here, the three main cores that I see in this part of the world, that is the Middle East, Africa, and the Indian subcontinent, is obviously polyurethane, typically called PUF panel in the subcontinent, sandwich panels here in the Middle East. It basically it's the most basic of or elemental consideration when you use a polyurethane panel. Gives you fair bit of insulation property. It has unfortunately low fire safety and it has got very high smoke generation, although it's lightweight and it's very cost effective. So if someone just wants to go for economical construction, PUR core is the best option. We then have the PIR or polyisocyanurate core, which actually these days has come a long way off the PUR cores in terms of its performance. It does provide the best in class performance, and it's kind of an ideal mix between what you see to your left and your right, which is the polyurethane and stone wool. It gives you a good combination of fire safety. It gives you a very good performance on the insulation. So basically, you have an ideal mix in PIR, which we'll talk about in more detail. It's slightly comparatively higher cost if you take a PUR panel as a base measure, and it's lightweight as lightweight as a PUR panel though. Less smoke emissions. It's good to use in smoke sensitive buildings. And then we move on to the stone wool core, which is obviously, it comes usually with the A2 class fire rating, which is in a sense non-combustible. The stone wool in its inherent property doesn't ignite, doesn't catch fire. So for smokes and fire sensitive buildings, that is the product of choice. Also, it has got excellent acoustic performance compared to your polymer based panels. So it's used a lot where your sound attenuation is a criteria. As you can see probably in the picture, you can give panels.
Sorry, Mr. Shrini. Sorry, I'm so sorry to cut you, but Sheetal is sharing and we can see this testing and performance characteristics.
Now it's the correct slide.
Yeah, now we are on the choice of insulation core material, right?
Yeah.
Perfect. Okay, sorry, sir. Continue.
I mean, is that the screen that you see now? Okay, so I can continue.
Yes, sir. We do see that screen.
So, compared to polymer-based panels, that is PUR and PIR, if you take a like-to-like thickness of insulation to be achieved, then obviously you need to go for a thicker panel when it comes to stone wool. They are therefore usually much thicker, almost double in the thickness of the core compared to your polymer panels. They therefore come as heavy to handle and a little bit higher cost in terms of materials, and your transport as well as application costs are slightly higher. Can you see the next screen now?
Yes, sir.
Can you see? Okay,
Yes.
This is the comparison. So the headline is comparison of course. It's okay?
That's right, sir.
Okay. So I've done a little bit comparison of PUR, PIR, and stone wool. As I said earlier, maybe I'm even repeating here, but look, PUR cores provide basic thermal insulation with a low index of safety, and especially when it comes to fire and smoke. So if it's a non-sensitive building to fire and smoke, and if someone wants to fit in a budget, I think this is what mostly is used even today in the subcontinent. The Middle East market is slightly changing. It has in fact changed a lot. It is tending mostly to use PIR. Ali probably might be knowing African markets, more of PUR. Ali?
Correct.
Okay. So anyway, look, things will evolve, and we will see a better use of core choices in the future. So people might shift to PIR, and it's, as you can see in the signs below PIR, it provides excellent energy saving. It is fairly it provides good protection against fire, doesn't add to the fire or contribute to the fire in a building, and it's got very low smoke emissions as well. As you can see on the screen here, this is a comparison of how the different cores add up. Now we, as Kingspan, have come up with a product called quad core. So in a sense, a 90 quad core panel gives the same insulation as a 200 stone wool, and this is about 110 of PIR, and about slightly more than that is the PUR. So that's your difference in thermal performance between the various cores. However, having said that, when it comes to fire, your stone wool panel is the best. That comes with the A2 class, and most of them achieve fire rate resistance actually, starting from 60 minutes going all the way up to 4 hours, which is a bit ludicrous. But I mean, panels do achieve 4 hours fire integrity, which is fantastic. Yeah, so stone wool is, again, like I said, best in class when it comes to fire and smoke safety, and it provides excellent insulation for acoustics purposes, but it comes with a price which is the highest cost among the three. Next screen visible?
Yes, sir. Insulated metal
Okay.
panels.
So now that's the choice of cores as far as the panels are concerned. A very important aspect, as other panelists might be congruently agreeing to, is the design of the panel. Now, typically for a roof panel, it's just a side lap joint. There's nothing hard and fast. It's basic. It's a basic design. The challenge lies in the other types of panels. Now, when you say roof panels, people think it's basically this trapezoid kind of a panel, but we have come up with multiple choices. Even in standing seam, now we are integrating the same technology. So now we have standing seam insulated panels, which is again a unitized product, and the jointing is much different as you see from a regular trapezoidal panel. The most challenging, obviously, is the wall panels, and there are a multitude of choices available. Some are conceal fixed, some are through fixed, and some have a inbuilt factory seal, which basically helps in keeping water and moisture and air out. So it provides a very tight seal at the joints. Most of the design failures that I have seen, and probably the panelists will agree, or even some of the viewers will agree, is a weak lap joint. That is where most panels fail, because it warps, it sometimes kings, it structurally fails, it lets, in the worst case, a lot of air leakage. So if it's an air conditioned building, you might actually make the air conditioning system work much harder, because the heat inside, sorry, the coolness inside is being lost through the joints of the panels. So I'm sure manufacturers over the years and even decades have worked a lot in bringing you the best lap joint, which does the performance of providing you high thermal performance, high energy efficiency. The less the leakage through these joints, the better the panel performs. And obviously it does the job of giving you the best moisture, weather, and air infiltration seals, as well as providing you a good structural integrity, fire performance, because again, that's the weakest point in a panel, where the fire goes through or the smoke goes through. So you need a well-detailed and a solid joint to keep the fire elements out of these joints. And obviously, if you have a good detailed joint, the panel looks much more aesthetic, especially on the elevations. So these are the rigors of designing a panel, and most manufacturers, I think, are doing a good job, because panels are increasingly being used more and more in construction. So that's a step forward. Moving on, I would like to talk a bit about, because we are concentrating on polymer-based panels, PIR core panels. There is a lot of work going on, especially with some of the big manufacturers, involved in advanced R&D. So the trends that we see these days is obviously a lot of work going on in the core chemistry and the paint coatings that go on the metal facings of the panel. A lot is being done to use more of plant-based or bio-based and recycled content in the polyols that is used in the system. And we are proud to say Kingspan is actually the forefront of coming up with these natural choices. They are more expensive to produce, but we are reducing or we are basically implementing increased chemistries in these mixtures to make sure that we produce bioefficient, basically bioefficient feedstock. Also, the low carbon and life cycle analysis are being done on the polyols. So we are aligning our goals with our supply chain to make sure that the carbon footprint is minimal in our supply chain. Life cycle of the products are aligned with our goals, which is long term. We are actually using, and I'm sure a lot of manufacturers are now using upcycled PET bottles, which is recycled plastic bottles basically, in the production of polyols, which is again a step towards sustainability and recyclability. And then I think there is a lot of research going on in getting the right balance between, I'm getting a bit technical here, polyester, polyols, and the higher hydroxyl mix for improved thermal and fire safety performance. Again, it's all down to the chemical analysis and the mixture that goes into the production of polyols and the MDIs that we use. There is clear focus on sustainability and circularity. Again, we are increasing the parameters and reducing the overall content that goes to landfills. I have come across a few examples where, for example, the polyurethane foam, once it is stripped of the metal, if it's a recycling job, that polyurethane foam is being powdered and mixed with concrete these days to make a lightweight concrete that in fact, exceeds the structural capacity of raw concrete. So a lot of these products are being used and mixed around to produce better materials, for better sustainability and recyclability of the product. And of course, as a group, Kingspan is proud to say that we are having the minimal waste disposal landfills, and I think the goal for the group is by 2030 there will be zero contribution to landfills in all of our sites worldwide. Right. So we move on to the facts and the figures, and I made it in red because unfortunately the reasons to switch to IMB panels are crystal clear in front of you. Although we blame the motor industry and the power generation industry for polluting the air, if you see the carbon emissions, it's a lot that as a construction industry player we contribute to it, to that. It is 37%, which is staggering. Also, the maximum amount of global landfills is contributed, unfortunately, by the construction industry, almost a third of it. As of today, only 5% of concrete used in the construction is recycled, it is getting better, but there is a lot to be had because concrete buildings leave behind a major carbon footprint whenever they are used. And also, concrete typically uses a lot of water, as all of you know. So 9% of industrial water, which is mostly fresh water, is used in the production of concrete. I'm glad to actually say my limited stint in India, I could see a lot of end users and developers because of this very issue of getting greener in construction, or in their methods and choices of construction have moved on to panels. I'm very happy to say that. So basically, IMPs, they provide an ideal combination. It's of engineered performance, it's a rigorously tested product. It gives you a lot of energy and substantial energy savings over the period of the lifetime of the panel. It's very cost effective and it's aesthetically pleasing. And like I said, it integrates with most elements that go on a building. So the technology advances as of today is pushing towards higher use or percentage of pre and post consumer recycled materials. and most manufacturers are pushing for reuse steel, recycled steel. I think in Europe they are using very high percent. In fact, one or two manufacturers that I know are using up to 90% of the metal facings with recycled steel, which is expensive, but that's a commitment towards providing a greener product. Right, moving on. Look, the applications. Obviously, most of us or most of you who have joined in will be knowing. But industrial construction, typically factories, warehousing, cold stores, clean rooms, which are for the internal use. Infrastructure projects. A lot of the transport hubs, be it airports, seaports, land ports, hospitals, schools, military buildings, commercial buildings. A lot of shopping malls tend to use insulated panels these days. Multi-purpose centers. A very notable change I see in data centers. I've experienced that, like I said earlier, in India. I'm experiencing it here in the Middle East now. Is the trend to get away with the typical concrete and even precast panel construction to IMPs. So companies are gradually adopting the use of IMPs for both external and internal use. It's actually being accelerated by some of the global companies who are having the data centers built here. They have used it in the West, and they're bringing that technology and forcing contractors to use IMPs, which is a great step. Uh, and of course, they are used for in modular construction as well, for prefabricated and temporary buildings, as well as porta cabins. It's a very light material to transport on the back of a truck for these small units. Right. Moving on to market trends, you can see on the right. In fact, I think one or two European companies, including us, have come as Kingspan have come up with this integrated solar technology, which provides a unitized construction, which has both the panel and the PV crystalline panel embedded in it. So it's a single unit that goes straight onto your roof. Also, there is a lot of engineering being done to maximize the closed cell structure, and there is a lot of use of nano and micro fillers for increased structural integrity and thermal efficiency of the panel. The content, the isocyanurate ring content and the reactive polymeric flame retardants are increased for increased char formation. I think probably Ali will talk a lot on this char formation, because this char formation on typically PIR panels is what gives it its distinctive characteristics of being fire safe. When the char forms on the face of a panel, it literally stops to react. The fire may be incident on the foam, but there is minimal flame height, there is minimal flame spread, there is minimal smoke emission, and that's what saves or stops the fire from spreading. So in short, the panel does not contribute to the spread of fire. Also, manufacturers are trying out intumescent coatings. It's expensive, but there are various kind of iterations being tried out, so that the panel face itself provides a barrier. The fire doesn't get into the core. Also, there are other sacrificial coatings being tested where when exposed to fire, they form a shield for the fire not to penetrate the insulation. It may take probably a few years for these panels, for this kind of technology to come into our markets. And typically there are also highly reflective solar paints available these days, which reflect the heat, obviously increasing the efficiency of the panel. We have tried on some of the coatings here, and it's actually has had very good results overall for the panel performance. Right, saved a few screenshots of what the global trends, in India and the projections for the global market are. As you can see, in the global market, there is a mixture of cores, including, I was surprised, a lot of extruded polystyrene and expanded polystyrene. Still, that blue lines that you see here is all EPS and XPS insulation. So a lot seems to have still been used. This gray is our bit, which is the polymer PUR-PIR bit, and there is also other kinds of insulation. But the trend is very progressive. It's showing a good market increase over the years as we go on, as we move on for the next 10 years or so. The Indian market also in particular has a good scenario. It's got almost a 10% CAGR projection. which will be good for the local players there. In terms of the global markets, you can see where the main the growth is going to come from. Obviously, the APAC, Indian subcontinent included, Australasia, and obviously North American markets are still one of the leading markets globally. So this is the general projection for the product across the globe. A note on sustainability. This is basically, look, I haven't put Kingspan at the top of the group. This is what came from the internet. I just copied and pasted it. Some of the companies listed, most of them are European American, with due respect to all the manufacturers who are on this call. But you can see the drive towards sustainability, renewables, minimal waste, water conservation, lead support. It's a very encouraging step forward, where ultimately panel manufacturers will achieve their goals once the goals are aligned within the industry. I will not dwell much on this. I would like to showcase a few projects that we as Kingspan have done. So bear with me for being a bit partial here. This was a project done like about a year back, Maersk Logistics Park. It was a fairly large building, as you would see, use of roof panels, wall panels, and cold store panels. And Maersk is one of our corporate clients. They generally support us a lot worldwide wherever they build. In fact, I know that we have just backed a project in India as well. So yeah, they are continuing to support us, thanks to the team at Maersk. So as you can see, the panels are used externally and internally, and they were all quad core, the leading foam that we proposed. Komatsu was built here in Dubai, Jewelry Free Zone. This was back, I think, in 2019, 2020. You can see a mixture of panels. These are trapezoidal panels. These are flat panels. So they kind of mixed it up on the elevations, and they use it for the roof as well. And that's another of our projects which was done in the USA, which tends to use a lot of panels as well, and they use multiple cores. They have a lot of choice, a lot of players to give them multiple options. But again, there were challenges in here because you can see the integration of so many other trades, like 2,500 light fixtures and 7.2 kilometers of piping. So there's a lot of integration going on internally that the panels were being used at. This is in Michigan, I think about 3 years back. So to summarize what was just discussed, in terms of choosing cores, polyurethane is the basic, cost effective, but it's kind of it compromises on the fire safety, smoke emission safety. PIR and stone wool obviously do better in terms of fire performance and thermal efficiency. PIR stands out as being probably the best fit as of today. Obviously comes at a higher price compared to PUR. The selection of core obviously is mostly driven by the use case, which means if the building is a hospital probably or a data center, the building owner or the developer might go for a fire safe stone wool core. If it's just a basic shed, they may go for a PUR. If it's a slightly higher specification he wants, he may go for a PIR. So it's all user case, budget, and certain regulations, as Ali touched upon in the beginning. Civil defense regulations also drives the choice of cores. For example, PUR literally is non-existent in the Middle East now because of the regulations, local regulations that is required on these panels, safety. And I think what manufacturers, what we need to do is we need to drive initiatives. We need to research, come up with more environmental friendly, sustainable friendly materials, which reduces consumption, recycles a lot, and minimizes waste. And this should be, I think, the short and long-term goals for every manufacturer who basically manufacture these panels. Also, the industry regulators and government agencies need to be fully appraised of what is available to them in the industry, in each market that we serve. As long as they get if they're not aware, obviously they will not push the regulations. But once we make them aware, we see a very kind of helpful nature most come across, and basically up the ante in terms of how buildings perform generally, be it industrial, residential, commercial, whatever be the case. I think with that, I come to the end of my presentation. I hope I've not gone short past the time, but I do apologize if I did. If you have any questions, we can take it later, right, Zainab? We can keep the questions for later.
Yes, yes, sir. We
Okay,
shall.
thank you very much. Do I stop sharing or?
Yes, sir. Your
Okay.
Sheetal has stopped sharing on your behalf. Mr.
Okay,
Cetiner will take over now. Thank you.
thank you.
All right. Thank you very much, Shrini. I hope everyone can see my screen. We're having this
Yes, sir, we
issue.
can.
Okay. So obviously everybody knows Kingspan, so there's no need for introduction, but let me briefly introduce AlexForm. I'm the CEO of the company. AlexForm is based in Egypt, and it's been in the steel industry market and insulated panels market for the past 65 years. So it is quite extensive history with following engineering practices with innovation. So I'm here today going to talk about the panel's fire properties, focusing on it. But before I go there, this is a nice 3S I like to talk about, which is sealed, secure, and sustainable. This is actually what the panels bring to everyone. So as panel users, as panel producers, as consultants, specifiers, there are certain criteria that you would be looking for while selecting which type of panel to purchase or use or specify in your project. I'll briefly touch base on these criteria, which I put it classify into 4 categories. One is the thermal performance, the other is durability, environmental concerns, and of course, loss prevention and the specific of fire performance, which I'm going to talk about today. Briefly talking about them, the thermal performance, the keyword for you is the lambda value. You must have all heard about this. PIR foam has the best-in-class industrial insulation levels for any insulated product in the market. I'm not saying the highest insulation, mind please, I'm saying best-in-class. And we should look at, as engineers, as designers, of the optimum solution, right? So definitely there is materials that has better insulation than PIR core, but they fail in other aspects like maybe the weight, maybe the cost, maybe other strength, let's say. So PIR foam is the optimum product designed to meet the needs of the construction industry in a lot of these aspects together. And when we compare it to, for example, to EPS, you have 1.5 times better insulation compared to rock wool. It's twice as good as rock wool. So it's a no-brainer when you're talking about industrial insulation. PIR core is the best. And of course, for the thermal performance, the air and water infiltration plays a big role because these degrade your insulation purposes. So as Shrini mentioned, the panel joints should be designed in such a good way that they maybe not totally eliminate, I would say, but based on certain interactions, you can totally eliminate by using auxiliary items, but it should minimize these leakages. Then, of course, the foam structure should have a homogeneous density, and the foam should be having a good integrity, no holes in it. The density should be the same across the whole cross section. And obviously the joints, because we can only produce these panels with a certain width, and in that case, you're bound to have joints, and the joints are your weakest point. The most important thing for the joints is that it should have one strength, stability, and the insulation should continue across the joint. So the foam-to-foam connection is really primarily important. Yes. I would like to emphasize one thing here. For example, certain customers, they talk about, I want to, somebody making comment?
Just no discounts.
Okay, so some customers are saying, I want the panel joint to be 0 gap. And I tell them, look, this is not the criteria you should be looking for. You need to be looking for the foam-to-foam connection, because if your foam is not connected, it doesn't matter if your outside facers are connected. So this is an important point. Next is durability. The panels are one of the, again, very lightweight but strong elements due to its composite structure, which means, obviously, we all know they are made of thin sheet metal and the foam core. But once these are produced, they become an element that acts as a singular item. It's a composite item. It's no longer 3 layers. It's a one single element. This gives it enormous strength and also, of course, ease of use. And they are very low maintenance products. Practically, the only maintenance you should do on a panel is just to clean them, honestly speaking. So you just put it in place and then you forget about the panels, go clean it time to time, and that's all you need to do. Of course, durability comes with the structural integrity of your panel to be intact for a long time, so it shouldn't lose adherence of the sheets to the core, and the core should not shrink over time. And these are all controlled by the manufacturers through good production practices, let's say. A panel, because of the metal facers, is a very effective vapor barrier. It's important for modern buildings. And because it doesn't absorb water, it has a lifetime insulation. So, for example, for rock wool, you have this risk. If you don't protect it properly and if it absorbs moisture, you can forget about all insulation. One thing you need to consider is the corrosion protection. That's one of the weaker or concern points for panels because of the metal facer. But there are, of course, again, with the right choice of the top coating, with the right choice of the substrate, and post-production measures that you can take to prevent corrosion for many years, up to 40 years, you can get actually corrosion protection. So obviously here in the durability, installation good practice plays a big role. No matter how good your panel is, if the installation is not good, it can still downgrade the performance. Coming to environmental, these are obviously the last decades buzzwords. We have green building regulations that we need to comply with. We have LEED and STDAMA scoring for projects. And recently, European Union announced that if your product is not below a certain carbon footprint, you cannot even put it into European market. So this is coming up along with your company. As a company, you need to be having a certain level of carbon footprint, and your product should also not embody too much carbon. That's why the lower embodied carbon terminology you will start hearing, especially from Kingspan recently. Then the products itself, because of its zero ozone depleting blowing agents we use in it, because it doesn't off gas once the production is complete, it has a very low global warming potential. These are all adding to the sustainability goals that you have for your projects. SRI, the solar reflective index value, this in certain legislations, it is indicated what is the maximum value should be. If I'm not remembering it wrong, in UAE, for example, it should be maximum 78 for roofs, which means you can only use either white color or one of those solar reflective paints that Shrini talked about. So all options are available. And of course, when we're talking about PIR core, it's a fiber free, so you don't have any floating light fibers that can create health issues. It's bacteria free. It is fungus free. It resists insects. I mean, looking at all of this, is literally, this is a wonder product, right? The sandwich panels, insulated metal panels. We are quite a fan of this product, and we want to make sure the world also knows more about these panels. Coming to the last topic, which is my main topic today, is the loss prevention. You put your investment, you spent a lot of money in it. You would like to make sure that you protect your investment and what is inside it. So here in loss prevention, we'll talk about the panel's fire performance shortly, but as I said before, as much as the panel itself, the installation and operation practices are very important in ensuring an overall comprehensive fire safety for your building. It's not just the panel. So don't think that I put the panel and there's nothing is going to happen. It's not like that. It has to be installed properly as it is tested, and it has to be operated properly. I mean, the facility. So don't think just panels, but the full system that is required to install your panels and how this installation is designed in your building, taking consideration about fire risk or thermal risks, condensation risks, all come together. Obviously, conformity with updated legislations, civil defenses around the region, And like I said before, UAE is leading this when I started in the UAE about 17 years ago, it was the first country that came up with civil defense obligations for the manufacturers of panels or any building element to have in place. So we'll talk about fire spread versus fire penetration or resistance shortly, and obviously it's not take my word, wallah. it's not that. You have to show that I have tested this product and I have certified it by third parties. That's how, Mr. Customer, you can trust me. That will be the proof against low-grade materials, because even in PIR, there is low-grade PIR available in the market. So what sets a good manufacturer and a good fire-performing panel from the other is this testing and certification. So let's dig into the fire safety testing and certification a bit more in detail. I will keep this less technical, first of all, because I'm not too much technical myself on this, but also I think it will bore the audience down. So I'll try to keep it in a level that is touching the topics, talking about the buzzwords and what it means. So first of all, panels are passive fire safety elements. They don't extinguish fire. So don't trust on the panel to extinguish your fire for you. They will try to not promote it. They will try to contain it, but they cannot extinguish it. Having said that, how to define the performance of a building element, building material in case of fire? What we say is, in case of a real fire, a building material, aka panels, should not spread fire, should not spit out burning droplets or emit excessive smoke. It should preserve its integrity and heat insulation properties for a certain period, so that it can provide enough time for the living beings to escape fire, to evacuate the building, and the fire brigade to fight the fire, thus prevent possible life and property losses. It's equally important because I've seen many cases with my own eyes that the firefighters, they come to a fire, but they cannot get in because the fire is so like an inferno. It's everywhere and it's ablaze. They cannot go inside. They just take the perimeter protection and then they let the fire burn away the whole building because there's nothing they can do. So in order for the firefighting to even fight the fire, your building materials should themselves have a certain level of fire resistance so they can actually trust what the material is, and then they can go inside to fight it. As per Fire Stop Contractors International Association, the event, let's first understand where the panels come into the picture, the fire event timeline. So in most cases, a fire in a building, in an investment, it starts from electrical short circuit or something. We keep hearing this post-analysis of fires. So it starts with, so the fire starts in a cable. It gets overheated, short circuit, and then puff, its self-ignition temperature is exceeded and just goes into open flame. At this stage, you're lucky if the smoke detectors catch it. If they don't, you're in trouble. Then it starts growing and it starts propagating to spreading to other items around it. And again, if the fire suppression system, they start trying to extinguishing, which is the active extinguishing system, you're lucky.
Yeah.
If they catch, fine. If they cannot catch, then this fire starts propagating, meaning spreading along the interior surfaces. And this is where the first reaction to fire element comes into play, where we'll talk about it briefly. This is the first property in fire safety of panels or any building material, but I'll consider panels in this presentation, obviously. So the first, there's a small flame, it's exposed, and now your panels are facing this. This is the stage you're facing it first time. But the fire load is too much, the heat load is too much, and then it goes into a flashover. Now you have a full-fledged fire inside the building, inside the room. And this is where the fire resistance comes into picture, trying to contain that fire. If it can be contained, well and good. If not, then this fire goes into adjacent rooms, to all parts of the building, and the structure is lost. So based on this, we talk about three main criteria of fire performance classification. When you will hear, I want fire-rated panels. So what do you mean by fire rating? This is the question that generally I ask the specifiers, the consultants, or the customers, like, what do you mean by fire rating? Which one do you want? Because there's 3 levels of this. There's first the reaction to fire, there's the fire resistance, and then the smoke generation. And this is what we'll be talking about in detail now. So to show it better on a visual, this is your, let's say, warehouse, and the fire started in the corner. So reaction to fire, as we said, is the first step, that it sees the fire, the panel is exposed to the fire. This reaction to fire classification, it will try to determine the flame spread and the propagation, how much the material allows the fire to grow on it. The question it asks is, can we keep a small fire small? This is the first step. You couldn't keep it, it goes into a full-fledged post-flashover fire condition. Now the fire resistant tests come into the picture. They try to see how much your material, your panel, resists the passage of heat and flames through its body to contain an already developed fire. And in the meantime, the fire is burning, there is smoke getting generated, and this is as dangerous as the fire itself, because it is another factor that actually destroys your goods stored inside, or it also deters the firefighting to get in and fight the fire. So the smoke generation tests determine how much smoke is generated by burning material. So reaction to fire tests, what they do is, through some relatively smaller scale tests, they try to determine how much a material will promote and spread fire. And when I say smaller, I don't only mean the specimen, the test size itself, but also the fire source can be small, like a small flame or a single small lesser heat load, let's say. So it focuses on combustibility, self-ignition temperatures. These are the important things in a reaction to fire classification: surface flame spread level and smoke growth level. And these are the tests you may be mostly hearing in the industry, which talks about reaction to fire, because there is European norms, there is American norms, there is comprehensive test standards, there is, and you'll keep hearing this. And the most common is the 13501-1, which is a reaction to fire classification standard, Euroclass, which replaced the old DIN 4102 standard by the Germans. This is where you keep hearing A1, A2, B1, B2, and that kind of stuff. I will dig into this very shortly. ASTM E84 or NFPA 255 was a staple test for a long time in the industry, again, for the flame spread. And 285 is another important one, that is for the exterior walls fire spread test. And then there is LPCB, which is a UK-based comprehensive testing body, and then FM, famously, of course. These are the types of reaction to fire tests that the industry talks about, and most civil defense approvals base their approval on a combination of these tests, basically. So, for example, ASTM E84 Steiner tunnel test. This is where you see class A, B, C on a product. It's a 7-meter long tunnel, which they put a 60 centimeter wide sample in it. They light fire from one edge, and in a certain duration, they measure how much that flame spreads along the length of the panel inside. According to the flame spread level, they classify, and the smoke generation level, they classify as A, B, or C. Now, this is easy to achieve for a panel. Even a normal PIR or B2 PU can achieve class A if it's with a facer. You can run this test with a facer or with a naked foam. And it's almost impossible, not impossible, very difficult to achieve class A with a naked foam, but there are foam systems that allow this to happen also with just foam itself. And these foams are also available in the Middle East. In the past, you could only find it in the US, but now in the Middle East, you can find foam grades that are allowing you with a naked foam class A. Then the European norm is there, which is a 13501-1. This is now the de facto standard for reaction to fire classification. And here you will see this A1, 2, B, C, D, E classes, which in the past it was B1, B2, B, C class, etc. And that's for fire, the main classification. But there are subclasses also for smoke density And for burning droplets, this goes back to remember what we said in the beginning, that the building material should not emit excessive smoke and should not spit out burning droplets. So with the PIR core, a good PIR core panel, the maximum you can achieve here is BS1D0. And this is good enough for most fire regulations, unless there's a specific minute-based, fire resistance required for reaction to fire. This is the maximum you can achieve, BS1D0, and this is what you should achieve from a reputable supplier, honestly speaking. A1 and A2 are reserved for non-combustible materials. Rock wool, for example, mineral wool is A2 class. But again, you see the test is relatively smaller size. It's a 0.5 meter and then 1 meter wide panel with a 1.5 meter height. And even the ignitability test, the small frame test, is just with a 25 centimeter foam. So these are reaction, because like we said in the beginning, a small source of flame is there, and how your core is reacting to this is trying to answer this. And comparison with the old standards, so this is, I think, is important, because when you hear someone saying B1, B2, I think we should start ignoring these from now on, and industry should really switch to EU standard, the new standard, which talks about BCDE. Because when you say B1, as you can see in the new standard, B and C can be B1. You never know if it's a B class or C class. So it's better to talk about the European norm and ask for the B class form, which is a better fire resistance, obviously. But still, certain parts of the world, they refer to this standard. They refer even without knowing that they are referring to it, obviously. But when somebody says B1, let's invite them to talk about the EU classification 13501-1. Another reaction to fire, and an important test in my opinion, is the NFPA 285 test. This is again a part of the civil defense requirements in the region, and this is the fire propagation of exterior wall assemblies containing combustible components, which is directly described in our PIR panels. And the testing rig here is a 2-floor testing with your panel fixed onto it with an opening in front of it. They light fire here and they light fire here. What it wants to see is that this fire should not reach the second story internally, and this fire on the facade should not go above a certain level vertically or horizontally, should not spread too much. And the temperature rise on the outer face should also be within a certain limit. If you are within these limits, if there is no fire within the second floor, then you pass this test. This is a pass or fail criteria test. Now you see the test standard, that the sample size has grown a bit bigger, more representative of an actual condition, let's say, because here also the panel joint is affected. Now we go to the fire resistance. Like we said before, fire resistance deals with how much a material resists the passage of heat and actual flames through its body. To contain an already developed fire, it tries to determine how long the material shall withstand fire. And this is directly minutes. We're talking minutes here. Will it stand 30 minutes, 60 minutes, 120 minutes, or 4 hours? So when we talk about these are the test standards that you will most commonly hear about. BS 476 Part 22 EN 13501-2 this time. This is for the fire resistance, but this is a classification. So Europeans like to make it complicated. This is a classification standard that uses the test data from these tests to classify your product according to certain minutes. So the actual test is 1364-1 or 1365-2, based on what you're going to test it for, as a wall or as a roof. And then ASME 119 is a comparable test to this one. And then there is also in the Civil Defense Code, there is this test, 13501-5, fire classification of construction products. For roof, what is required is the top requirement, B roof T4 class. This I put here under fire resistance, but it's not. It's a hybrid test. It includes, again, flame spread measurement, etc., but also measures fire penetration. So the test is run for 60 minutes. At the end of 60 minutes, there should not be any fire penetration. But of course, this will not give you, if it is withstanding the fire longer time, you will never come to know. So this is not exactly a resistance class, but it's better to include it here. Now, the most famous test for fire resistance, you will see this everywhere. Let's talk about this a little because it's an important test. When you need a firewall inside your investment, and you don't need it everywhere, let's be clear here. For most projects, the building codes do not require a firewall unless what you're storing here inside is extremely flammable, or you need to segregate the risky areas from the non-risky areas. Then you need to put up these firewalls, fire barriers. And for that, this test is applicable. You put 3-meter long panels on this opening, aperture, and behind here is a furnace. And inside is real hell. And I've seen it with my own eyes. Inside it becomes a pure inferno ablaze. So you have up to 850,000 degrees Celsius inside. So this is a fully developed fire. What you want to see during this test is on the outer side, the face you're looking at now, the temperature should not rise above a certain level. And you should not see any sustained flame coming through the joints. Like we said before, the joints are the weakest point in panels. So if there's no joint, this will withstand fire forever. There's no problem. But because there are joints, the fire will deform the joints and will find a way to go through it. So the longer you delay this by sound installation practices and materials, the more fire resistance you will get. And there is another version of this where you test for the load bearing. And in that case, you also don't want to see deflection on the panels in case of fire. So when the test is running, what you will see is that after some time, the smoke will start coming through the cracks because on the other side, the fire has already deformed the joint and started eating through your foam core, trying to reach the other side. And after a while, you see the flame coming through. And it's not like a short flame doesn't fail the test. It has to continue more than 10 seconds as a fire. Then they stop the test and it's failure point. So this is the fire resistance, most famous fire resistance test. And it will give you results like, for example, EI30, which will mean this panel withstands fire for 30 minutes without losing its thermal insulation and without letting the fire go through it. With PIR panels, with 200 millimeter thickness, you can achieve 2 hours of resistance. And this is more than enough for, I would say, 90% of the projects, which should give you an idea about the comparable performance of PIR foam versus mineral wool panels, basically. Now, smoke generation, this is two tests are there to check the excessive smoke generation in case of a fire. One is the 13823 European test. This is the small chamber test that is used in the reaction to fire classification for Europe, and there's the factory mutual FM 4882 test that run this, and these are the settings for this. As you see, this is the corner test, and this hood here continuously collects the data on smoke generated and gives you a result. And FM 4882 does this with the parallel panel test. They light fire at the bottom, and there are two panels here, one on here, one on here, and you can see the scale of the person here. This is a 7 meter long panel, and they see how much smoke is generated along with other stuff, of course. Now, the last topic I would like to talk about is the comprehensive fire certification, because what we have spoken so far is mostly individual testing and classification standards. You run one test and there you go, you have this test report. But several European and American bodies saw the need for this larger scale comprehensive fire certification. And two of these bodies are most famous, the Factory Mutual FM from US and Loss Prevention and Certification Board, LPCB from UK. These bodies, they don't run a single test. They run multiple tests on your products. And then they also audit your facility, like a quality audit, to make sure that you're going to deliver what you promised to keep delivering. So it's a comprehensive scheme, not just a test report. I will choose the Factory Mutual for a bit picking out more here, because this is a more, let's say, globally accepted version. They have offices around the world, and their name is used, let's face it, more than LPCB. So FM Approvals is actually part of FM Global, which is an insurance body. And the story here is interesting because I'm telling this because this should give you the peace of mind in a certain aspect. FM Global is an insurance company, and FM Approvals is their testing and certification body. So what they do is, if your product is FM approved, they can insure you. If it's not FM approved, they may still insure you, but you'll have to pay more for it. So with FM approved products, you have a premium advantage, let's say. What this tells you is that insurance companies, we all know them, right? So if they are accepting to insure because an FM approved product is used, this should tell you how much they trust in their tested products. And you, as an investor, can also think that, okay, this is an acceptable product that it will perform in case of a fire. This is why I told you this. So the important thing here is that the approved suppliers and their suppliers, I mean, the panel manufacturer and their suppliers of foam, of screws, of whatever they use for installing the panels, they are being audited every year, sometimes twice a year. So FM is doing your job as a customer, and they are testing and surveying and auditing the supplier just to make sure that the supplier is keeping his promise to deliver a tested product. So for the insulated metal panel supplier, which test standards are relevant? It is the 4880 for internal wall and ceilings, and 4882, the smoke sensitivity. For 4881, which is for exterior walls, the facades, architectural facades, the hidden fixed panels, you will hear more, or concealed fasteners. The panels that you use on the outside of a building is for the standard. And finally, 4471, this is for roof assemblies. So it's not enough if your supplier tells you, I have FM. You need to ask which FM you have. Do you have it for all? Once you achieve all of these as a panel supplier, you can proudly say I'm FM approved in that matter. And these are the tests.
Sorry, Mr. Cetiner, can we wrap it up?
Yeah, this is just the last slide anyway, so don't worry.
Okay, thank you, perfect.
Yeah, so these are the tests. Like there is 15 tests and in FM approval, and there is 10 of them at least they run for each, for the panels at least they run to give you FM approval. And to show some photos of their testing, this is a corner test. You can see the intensity of the fire there. That's a whole wooden crib in the corner burning. This is the parallel panels test I already showed, and this is for measuring the flame spread above the roof, and there's an external source of fire. So yes, this is the end of my presentation. I hope I have been able to convey certain key characteristics and key performance testing in terms of fire. We will have a question and answer session anyway. At this point, I think I will leave the stage to my colleagues, Mr. Satish.
Thank you, Alison, sir. Yes, thank you, Shrini, Menon, sir, for the presentation effectively done and highlighted how the next generation insulated metal panels offer a balanced solution for modern construction, integrating the performance characteristics and core material consideration and the crucial sustainability advancement. And Mr. Alexandria, sir, thank you for the presentation, provided a comprehensive overview of critical fire safety aspects and rigorous testing standards for PIR panels, emphasizing the role of passive fire safety elements. And now I will jump into my presentation as we are running out of time. Now let's dwell into our topic, sandwich panel in PEB industry, a game changer for industrial and commercial infrastructure. Before that, I will introduce myself. I'm Satish Kumar, Deputy General Manager, Sales and Marketing at Metalscope India, having 24 years of building system experience, driving the sales and marketing innovation in insulation and PEB industries, actively contributing for the Green Society for insulation and recyclable sustainability in the green construction. Yes, and who we are, and we are an ISO 9001 certified company. We are into the metal buildings. Pre-engineering building is our core area where we do the design, detailing, fabrication, supply and installation. And we have an installed capacity of 48,000 metric ton per annum. And we are a part of the Indian Green Building Council member. And before entering into the presentation, as I said, my topic is sandwich panel in PEB industry, a game changer for industrial and commercial infrastructure. Before entering into it, we should understand what is PEB. So as well said, Mr. Ihsan sir, as well as Mr. Shrini Menon, we are talking about sandwich panel. What the sandwich panel had made a change in the PEB industry in this latest industrial revolution, it has taken a good place wherever if you go for an industrial application or for a cold
Mr.
storage.
Kumar, I think, Mr. Kumar, you will have to put it in the presentation mode. We are unable to see the slides moving.
Yeah. So before entering into the my presentation, let me understand what is PEB. PEB is a steel structured, engineered, fabricated, and assembled under a controlled condition. The key triads of this PEB are the custom design to specific needs, minimal on-site assembly, and faster construction. Think of them as a plug and play model for the modern construction. So by understanding this PEB, we can go to the next slide. Yes, the PEB revolution and the panel innovation. This is what the key area where we are going to focus. Initially, there was a conventional industrial building method that is we called as a traditional industrial building. Later, it has converted with the PEB with PPGI sheets with the normal single skin sheet, and now this has transformed into PEB with sandwich panel, where we are going to talk about more on this. And why this conversion has took place, because there was some flaws in the traditional building as well as in the PEB with the PPJ sheet, and we are going to see what are all the disadvantages which has made a transformation to shift to the sandwich panel industries. Yes, we can go to the next slide. Yes, before that we will understand the comparative chart of the traditional construction, that is the conventional method over the modern PEB industry. The first parameters we are seeing the construction speed, where the traditional method has got the very lower and intensive on-site slow moving construction was happening, whereas in the modern PEB it was very fast and the prefabricated off-site assembly takes very quick installation. Second one is the material used: concrete, bricks, wood, heavy iron rods, and non-recyclable products were used in the construction method. Whereas in the modern PEB, the pre-engineering steel, lightweight, reusable, and durable methods we were using. The design flexibility, yes, the rigid layout, fixed column wall, which cannot be modified at any point of time once it gets constructed. Whereas in the modern PEB, highly customizable, open spans, modular, in future expansion, it is easily adaptable. Whereas coming to the cost efficiency, yes, initially the cost will be high, and the maintenance cost, labor cost, and the material wastages will be more, because the maintenance will come on a periodic every 6 months. After the monsoons comes, we need to do the maintenance work at all point of time. Whereas in the PEB industries, it is very clear that there is a lower upfront and lower life cycle cost, minimal wastage will be there, and it is an energy efficient building can be done on this. Sustainability part, yes, low eco impact, high carbon footprints, limited in recycling, because sand, bricks cannot be recycled at any point of time. Whereas in this point where the steels can be recycled, even this polyurethane can be recycled in terms of steel, all the reduces the carbon emissions. Also, the recycled products can be used. That already Mr. Aliasan sir has covered it, this topic. Yes, ma'am, go to the next slide. Yes, the traditional building disadvantages are longer building time, water absorption in the concretes, and it will make the dampness, the post monsoon cost, that is expensive repairs for leaking and structural damages, limited adaptability, poor drainage, and roofing options. Whereas when we go to the PEB with, go to the next slide, ma'am, PEB with the single skin sheets, there is also some disadvantages. The main part, or it is six disadvantages we have identified. One is the condensation, induced the moisture buildup during heat and rain, where there is an peak summer is there, the heat radiates into the metal sheet building. This is the one of the major factor where the single skin sheet is transferred into the sandwich panels area. And the water ingressive via rain penetration, because of the joints of the single skin, the screw fixing, the proper installation is not happening in the screws, 100% the leakages will occur. The wind equipment, when there is a big opening is there, due to the sheets less weight thickness and the non-fixing of screws, may have a tendency to wind uplift on the structural will get damaged. And when it's coming to the corrosion part, yes, when it is in the seashore area and when it is reactive to the acid content, this has gotten very big damages will occur in terms of the corrosion, and the debris and impact, drainage overload, also will be happens on the rooftop, whereas the wind and rain. Go to the next slide. So where the environment impact on building, I have taken a typical region. I took India as a typical example because here we have the four types of monsoon climates we have, and here the high ambient temperature results high heat ingress through roof and walls of the buildings, whereas the similarly low ambient conditions result the cold ingress. If you see in the topmost part of the India, it is very cold, and now the people started using the sandwich panel in the cold regions, where in the topmost area, that is the mainly the PUR and PIR panels, they are started using it. And now in the other regions where the orange area shows, it is also a heat area where it's a moderate heat is there. Here also the most of the people start using the industrial buildings sandwich panels. Go to the next slide, ma'am. So we will understand the thermal insulation of the building. High ambient and high humidity result in uncomfortable working condition and the lower productivity. This is what one of the reason where there was a transformation took place from the single skin sheet to the sandwich panel. So what thermal insulation can do? It creates an envelope in the building, reduces the heat and cold ingress from outside also. Maintains at least 5 to 6 degree temperature. If someone says my panel is going to give 10 to 15 degree temperature, it will never give any 10 to 15 degree temperature. It is something around 5 to 6 degree temperature you can play around, and it maintains a controlled temperature for a longer period. That is, when you are into the air conditioned room with the sandwich panel, it will have this controlled temperature. You can maintain the temperature internally, so it will not allow the external heat to come inside. The human comforts and high quality of life. This pictorial image what I have shown here, it talks about where all the heat is exposed to a building. Up to 25% heat losses through the roof and up to 35% heat losses through the insulated walls. This is the highest part where you can able to see. Obviously, the windows, doors also plays a vital role. Go to the next slide, ma'am. So the traditional construction and PEB construction, yes, just I made a comparison of this. The design approval and the design and engineering, what we can able to do is in 3 to 4 weeks, we can do it in the PEB construction, whereas it takes 6 to 8 weeks in a traditional construction, and lot of approvals is required. Whereas in this design and engineering, we can able to take as per the government norms, as per the what the government says, how the building act, based on that we can able to get it done in 3 to 4 weeks. Whereas the foundation work, it will take 4 to 6 weeks. Here the same foundation time will be taken, but the component fabrication we can able to do it along with the foundation work. It will be 3 to 4 weeks. So enclosure of insulation, yes, assembly and erection, it will be 2 to 3 weeks. Whereas if you want to do any installation on that on the walls, it will take 6 to 8 weeks. Finishing works, it takes 6 to 8 weeks, whereas in this panel and installation finishing will be 2 to 3 weeks. Obviously, it will reduce around 50 to 60% faster than the traditional construction method. So now, now there is no traditional construction method for factory building. All the people have been shifted to the PEB constructions. Go to the next slide, ma'am. So the 50 to 60% of the project deliverability and 30% because of the lower structural weight and the designing build we can do it in an efficient way. So the sandwich panel is the core enabler for entire PEB sector for roofing and wall cladding, where I want to just share this. This is the integrity of building envelope and single component installation with structural and cladding. Why I am saying single component insulation is there is no cement, there is no plastering work, there is no any other additional insulation to be done on that. Only the sandwich panel will stand alone, will give the insulation property in the roofing and cladding. Whereas the factory precision manufacturing we can done cut to length, we can do it at the factory itself, and then we can bring it to the site. We can install rapid assembly, on-site assembly. Next slide, ma'am. So just we will decode the sandwich panel. I think most of them have spoken about sandwich panel, but here I am trying to decode the sandwich panel. The top sheet will be a galvanized steel or an aluminium. Its major function is to protect the weather weather protection, and as well as the load transfer. The insulating core might be PUR or PIR or the rock wool. It will act as a thermal barrier as well as the fire resistant, and obviously acoustic also. And the integrated joints is tongue and groove or a concealed system, whereas it will be a air tightness or structural continuity will be there. So you can able to see a typical sandwich panel. There are different profiles. I have taken a wall profile and then just I have shown it in this. So can we go to the next slide, ma'am? Yes. So I have this performance behind the conventional material. I have made it into two classified things. One is the quantified advantage and the comparative performance. When you see the center part of the on the right hand side, you can able to see the center part. It is the traditional building, whereas the when you are seeing the PEB building, that is the outer part. So the thermal efficiency is good and the weight reduction will be taken place easily when you are adopting the PEB structures. And the fire safety, yes, when you are going for a sandwich panel with the rock wool, the fire safety will be good in that. And the acoustic control, again, the rock wool has got the good acoustic control compared to PUR. Yes, PUR also will have the good acoustic control when it is increasing of the thickness. When you go above 100 mm, you will get a good acoustic. And whereas the installation speed, yes, obviously, when it's compared to the conventional method, this method will be working out. So the same thing only I have given because of the thermal efficiency in PUR, PIR in rock wool, we call it in the U value. So the U value will be 0.023 watts per meter degree Kelvin, where if you see the this is the thermal conductivity value, whereas the U value for the rock wool is 0.04. When it is for the cold, you have to go with the cold storages or you have to go with the PIR panels. When it is for an ambient temperature work environment and for the data centers, we can able to go with the rock wool. So when it is coming to the weight reduction, yes, 70% lighter than the concrete roofs and walls, reduces the foundation requirement and the structural load. When it is a fire safety, rock wool cores achieves 2 to 4 hours fire rating, where the PUR or PIR cannot achieve to that extent. When it is coming to the acoustic control, yes, it is 28 to 34 decibels. You can reduce. This can be you can able to see the roofing of the any airports. This you can able to feel the internal acoustic feel in that, because we used to do in the airport of 7 layers of roofing, where rock wool will plays a vital role in that. So the installation speed also 100 square meter per hour a crew can coverage, that is 10x faster time than the conventional construction method. We go to the next slide now. So pre-engineering building with sandwich panel provide the versatile, efficient and cost-effective construction solutions across the multiple industries. These structures offer superior insulation and rapid installation and customizable design. So where these sandwich panels are used widely, already Mr. Shrini Menon said has covered in his presentation. And just for an idea, just I have took some of the key areas where the sandwich panels are being used, mainly into the manufacturing process, food processing, automobile, cold storage, warehouses, textile, sugar mills, engineering, rice mills, as well as cement, chemical, education institution, pharmaceutical, beverages and distillers. Why these panels are used is because of these key benefits: superior thermal insulation and energy efficiency, rapid installation, and reduces the construction time. Effective building solutions, excellent fire safety. So for these reasons, we can able to adopt the sandwich panel into the PEB easily. Next slide. So again, this is same thing where the real world applications look into it, where is the logistic hub, clean room, and the retail centers, cold storages. These are all the things I have given the certification already. I think it's been covered. We can go to the next slide now. So this is the game changer quadrant where we have identified speed, cost, sustainability, and the flexibility. When you talk about the speed, 8 weeks a warehouse construction we can able to do single trade installation, process immediate weather enclosures, reduces the foundation of the construction time. Whereas in the cost, 50% of the lower life cycle cost will be there, and 40% of the faster ROI, 30% of the reduced HVAC load, decreases the labor requirement. When it's coming to the sustainability, yes, net zero ready building envelopes, 90% recycling component, reduces carbon footprints in transport, and in the minimal construction waste will be there. When it's coming to the flexibility, as custom fire ratings for specific needs, modular reconfigurability for the future change wide, compatible with the various finishes, we can able to get it done. Can you go to the next slide, ma'am? Yes, this is the Indian PEB transformation. Yes, as Shrini Menon has said about the sandwich panel, that is it is the 9.6 percentage of CAGR in 2030, where in the Indian PEB transformation is there for around 13.5 percentage CAGR. This is the source we have taken from the Grandview Research Board, and this is the market current market in 2024. They have assessed as 1.8 billion dollar. It is something that the projected in 2030 is 3.9. So make the key drives which make the Indian PEB transformation is the Indian initiative, that is the Make in India concept, and now we are entering into the other mode called ESG, environmental, social, and governance, where we can get the tax creditability on terms of the carbon footprints, which the company follows the carbon footprints as per the government norms. They will get a tax creditability. So the ESG refers the environmental, social, and governance factor that investor measures, where analyze a company's sustainability efforts from the holistic view. The four pillars of this help the business act responsibility, sustainability. These pillars are environmental sustainable, social responsibility, governance, and economic sustainability. Focus on how a company can affect the planet, people, and their financial health. This is how the ESG talks about. When we are adopting this into our PEB industries, we will get a tax credibility for an export products. So e-commerce, warehousing, and data center is booming in India. So when you see the sector leaders, manufacturing 48%, cold chain 22%, and logistic 18%, others to 12%. Go to the next slide now. So as I said, the future proofing infrastructure, yes, in 2024 already it started. As Shrini Menon said, rightly said about the Kingspan is already into the bio-based PIR course. Yes, it's 70% recycled content, lower carbon emission is there, and same thermal performance which they can achieve. And second thing is we are into the phase of 2025. There is a PV ready panel system, integrated mounting of solar roofing system into that. And in 2026, yes, already the team is working on the smart panels with sensor for the cold storages and for the other aspects where there is a controlled atmosphere to be maintained. So they want to see they are fixing the inbuilt sensor into the panels where they can get an IoT based system is going to work on this. You can go to the next slide now. So the conclusion, the new construction paradigm is the takeaway, that holistic performance, single system replacing four traditional components. That is, one panel can replace a wall, which includes of cement, water, plastering, as well as stone. All those things is there into it, where it will replace the entire system. The economical multiple, speed, efficiency, and sustainability, we will get an unbeatable ROI compared to the traditional method, where the sandwich panel will take a good vital role in terms of the PEB installation. So the strategic imperative essential for competitive infrastructure development. Yes. Call to action. Yes. Embrace sandwich panel not as a material but as a strategic enabler of next generation infrastructures. You can go to the next slide, ma'am. Thank you for your patience and attention. If anything is missed out, sorry for that. And thanks for UTECH for giving this opportunity.
Thank you very much, Satish.
Thank you, sir.
So, okay. I think the question and answer session is open. I'm not sure if questions are coming, but I see 3 questions so far. So I'll just take it up one by one. So I'll start with the one that is first and foremost my area. Since insulated metal panels act as a passive fire safety elements, what are the most important design or installation practices to ensure their effectiveness in real fire scenarios? Okay, so this is obviously quite a know-how that you're asking. I can understand it. As I said during the presentation, the panel itself is not enough. The installation and the design of the installation, what elements to be used are critical, because the joints are the weakest point. So when you're saying real fire scenarios, I assume you're talking about fully developed fire. So there's a real fire already happened and the suppressors couldn't extinguish it, and now we have a developed fire, which then goes into the fire resistance, obviously. And in that fire resistance scenario, the panels, and let's be straightforward here, the panels, because nobody can achieve this, when they are installed just with normal practices, their resistance time will be much shorter than installed with additional items. What I mean by that, if the securing of the panel, fixing of the panel, the screws used, how it is secured to the perimeter of the structure. Let's say you have an opening, so it is interfaced with the opening around it, but also the panel joints themselves, what you use in and on these joints, how you ensure that these joints don't deform too much too fast and open up quickly. These are what needs to be considered. So there is the answer to this is that there is definitely additional materials required for a fire barrier application. And again, because the joint, and if you just apply a fire to the body of the panel, then it won't really be high risk because the metal is there. It won't melt easily unless it's aluminium. So that's an important point maybe to say. Aluminium almost never passes the fire resistance test, fire safety test, because it melts way earlier than steel. So the panel should be steel when you're talking fire. And in that one, because your weakest point is the joints and around the perimeter of the panels, you have to take extra precaution to use strengthening materials, to use fire resistant sealants, let's say, and suitable screws. This is I think all I can say about this, but of course,
Sorry, with your kind permission, can I elaborate on two more things?
please.
I mean, that was a very articulated answer. I think to the person who asked the question, very often we see in actual construction practices, many of the designers and architects, and with due respects to their expertise and knowledge, what they fail to understand is I have seen multiple building designs where this typical scenario of fire resistance, fire rating, everything is defined in the specification, but the purlin, the basic purlin on which the panel sits, that is not fire rated. That does not have any intumescent or concrete coating which stops the fire spread or which weakens the purlin. So as long as the fundamentals of design are in place, and as Ali said, if you take care, again, on the second point, when you're installing the panels, if the panels are installed as per the manufacturer's approved detailing, and it might change from project to project, but as long as the panel manufacturer's detailing is followed through on site, which is very important, which is what Ali said time and time again, the installation part is critical. There should be no shortcuts. As long as this is done, your building will basically last much longer in the case of an unfortunate fire incident. So two things: the secondary steel protection and proper installation will save a lot in terms of life and property.
Thank you very much, Shrini. Yeah, so I guess that answers this question. One other question we have, with the construction industry contributing 30% carbon emissions, how can panels help accelerate the industry's transition towards net zero construction?
Question, if I can take that, Ali.
Yeah, please.
Look, yeah, it's a fantastic question. As manufacturers, as you saw in that list that I presented, there are multiple manufacturers trying out multiple things to accelerate this sustainability of basically going green. So as a group, I can say proudly that Kingspan is embracing something called low embodied carbon in their formulations of PIR foam, the quad core. The phase 2 of the development is now is coming with the LEC, or low embodied carbon, which basically traces how much carbon footprint is achieved or decreased as the formulations go forward. The second part is the steel, the metal faces. Like I said, companies are making a very conscious effort to cut down the use of virgin steel. They are going into recycling, and in Europe, because cost doesn't become as big a factor as in Asia or African markets. A lot of the metal faces that is being used is recycled steel. In fact, there are corporate entities around the globe actually who specify the exact percentage of recycled steel that needs to go into their buildings. So it's not only the manufacturers, even corporate clients can push this impetus into providing minimal carbon footprint based products, if that answers your question.
For sure, it should. Honestly, this topic of accelerating, I mean, by just using panels, you are collecting a lot of points in all these green building and sustainability schemes like LEED and Estidama. And of course, there are other factors in it, but insulation alone is a big factor. So the question becomes, at a certain point, how can we also improve the thermal insulation properties of panels, and how can we increase the recycled material usage in it and recyclability of itself? These are all questions that the industry is at the moment working, and like Quadcore, there is works on improving this thermal, the lambda value of the foam core a bit. But these are all coming with certain price tags attached, of course. Our hope that these things get also stable and more accessible in the future, so people can start using better products in terms of insulation. So one other question is, how do polyurethane foams compare with other insulation materials in terms of environmental impact and compliance with global quality standards? Mr. Ilhan, can you help us with this one?
Sure. I mean, I think Mr. Shirin made a good comparison, but in general, let's say polyurethane or PIR core is first of all an inert material. That means after producing, let's if you talk about sandwich metal panels, when we produce a sandwich metal panel, it has average 20 years lifetime warranty. It sometimes goes up to 40 years. For example, Kingspan has this for the IP and quad core technology, right? So in this time period, average, when we have a look the mechanical and let's say fire properties, in terms of mechanical properties, average 10% aging we have in terms of thermal aging, mechanical properties, tensile or let's say compression point of view. Those are really minor changes in the lifetime of sandwich metal panel. In terms of fire properties, I think there is limited studies about, let's say, how the reaction to fire or fire resistance is being changed, but it's mostly, as you say, it's 50% production. We can produce the best quality of panels, and 50% is installation details. That is integrity part, details of the, let's say, drawings. It depends on also, let's say, the sandwich panel manufacturer. Each manufacturers are having their own IP and design. If we have a look in the market, let's say. So when we club all this together, the core PUR or PIR method is really sustainable, and it has also, it is open for the modification. We can use, let's say, recycled content, raw materials, mainly nowadays is rPET, or we can use the mass balance approach, for example. I can say up to 85 to 90% of core material can be fully, let's say, via renewable sourcing or via mass balance approach. If we club all together, the 95% can be fully, let's say, sustainable content.
Thank
Um,
you, Ilhan. Yeah.
oh,
Do we have
yeah.
time or should we?
Yeah, there is actually one more question for Mr. Ilhan. What is expected lifetime and how to prolong for sandwich panels? This was a question by one of the audience.
I mean, I can give a feedback about the core material point of view. So when we design the core insulation material, PIR or PUR, so we are, let's say, targeting to comply the standards for the mechanical properties EN 14509 as a detailed, let's say, mechanical properties or durability test norms. Okay, so in the lifetime of a sandwich metal panel, these properties should stay in specifications. For example, we talk about the blister formation, right? So after the installation and when we have a, let's say, room for the expansion, we can see from the slides of Kingspan 3 plus minus 1.5. And for aluminium, it should be, let's say, much, let's say, much more because of the thermal expansion coefficient of aluminum is double, right? So during this, let's say, thermal stress period, whenever the let's say the thermal stress on sheet or facer is being more than adhesion in between core material and the facer, then we can start seeing the, let's say, at the beginning, small waviness, then we can start seeing the blister formation. Depends on how the, let's say, panel is being produced as per the processing conditions, and as well as the installation part. I mean, the construction design, evenness of the, let's say, panels, main structural steel, okay, purlins, for example, we also highlighted, right? So overall, the core material should have these stable mechanical properties. That means we can make a really, let's say, high compressive strength, but the tensile strength and compressive strengths are kind of after some level is being working in a reverse effect. Means better the compressive strength, we can lose the tensile adhesion, which is, let's say, or shear strength we can lose, right? From the studies, I can say tensile strength and shear are long-term more important than the tensile compressive strength. So there should be a balance from the core material. Should give us this lifetime 20 or let's say up to 40 years the usage or lifetime of sandwich metal panels.
So maybe I can continue a bit with the outer face of the panels in this one. Ilhan,
Actually, we're really thin on time right now. We might, we just
very
have 2
important,
minutes.
very important one topic again, because the external facers quality is very important in the lifetime. Doesn't matter if your core is very good, if your facer starts
Mr.
rusting or
Ali,
gets destroyed.
we are at time, so with the the webinar might just end. So just we need to wrap up.
Okay, I mean, yeah, I think we have like 5-6 minutes. Please, let's wrap it up.
Thank you.
Thank you.
So, thank you very much. In this case, thanks my colleagues for the detailed presentations, and it was a really pleasure having this. And thank you, organizers. Really, this platform is quite valuable in this regard, making us meet with our attendees. And I'll leave the stage for you to finally close it up. Thank you.
Thank you. Thank you, Mr. Ihsan. So, and if the audience has any further questions, please feel free to send an email to any of our panelists. The email IDs have been shared, so you can reach out to them. And with that, I would like to conclude today's webinar. A big thank you once again to our speakers for steering such a meaningful discussion. It was really, really very insightful. And to all of you for joining us from around the world. Your questions and participation made this session truly engaging. Stay tuned to our websites and social media for agenda updates, speaker announcements, and opportunities to participate. As I mentioned earlier, visitor registrations are now officially open for the UTECH MEFPU ASB show which is happening at the Dubai World Trade Center from 15 to 17 September. And the booking stand inquiries are now open for the UTECH show happening in India from November 13 to 15 in Mumbai. Links are shared in the chat, so feel free to register today and book your spots early. Until then, stay connected, stay curious, and we look forward to welcoming you at UTECH Middle East Foam and Polyurethane and Adhesive Sealants and Bonding Expo and UTECH India Sustainable Polyurethane and Foam Expo. Wishing you all a wonderful day or evening ahead. Thank you, everybody.